Welcome to a lesson on 3.8, which is writing equations of cubic functions. Make sure you like and subscribe. All right, so let's review what we did last class. Last class, we graphed cubics. So let's do it. Sketch a graph of f of x equals x minus 2, x plus 3 squared. So first off, one x-intercept would be at a positive 2. I know there's no multiplicity, so it's going to cross. My next x-intercept would be at a negative 3, and this squared means it's going to bounce on my graph. Let's look at my y-intercept. To find your y-intercept, we have to plug in 0. So I would have, real quick, let's talk about end behavior. So since this graph is positive, my leading coefficient would be x cubed. It's positive. My graph is going to start down low and end up high. Now let's find the y-intercept by substituting in 0. So I would have 0 minus 2, 0 plus 3 squared. Let's do some mental math. 0 minus 2 is negative 2. And then 0 plus 3 is 3. 3 squared is 9. So for a final y-intercept of negative 18. So this is what we did last class, where I would go to a positive 2 on your x-axis, a negative 3. And my y-intercept is somewhere down here at a negative 18. Drop that down. So since my end behavior is going to start down and go up because it's positive, start with your pencil down here. First number you're going to approach is a negative 3. I want to make sure to bounce off of it. So go up here, bounce off negative 3. Try my best. Come down to this y-intercept. The next x-intercept I'm approaching is a 2, and I do want to cross through it, so you can go ahead and finish off through it. So that is what we did last class. We took an equation and we sketched a graph, but today we are going to go backwards. So today they're going to give you a graph, and then you're going to produce the lovely equation. So let's get it started. Writing polynomials in factored form. So here's our steps to solving this problem. First off, you need to identify any zeros and multiplicities. So looking at our graph, they gave me an x-intercept at a negative 4, they gave me an x-intercept at a 1, and an x-intercept at a 3. So this graph is crossing, so it crosses, crosses, and crosses. So I know I'm not going to have any multiplicities. There was no bouncing. So I've got x equals negative 4 for an x-intercept, x equals 1, and x equals 3. And so again, they're all a multiplicity of 1. They're all crossing. The next thing I'm going to do is take these intercepts and write them in factored form. So I know an equation will start with y equals. I'm going to start with a because I do not know my a value. I know it's a positive, or no, actually I know it's a negative number because it's going down. So x plus 4 would become, x minus 4 would become x plus 4 after switching the sign. X minus 1, and then x minus 3. So that is step number 2. This is basically our answer. I just have to figure out my a value, and that's honestly where all the hard part comes in. So let's solve for our a value. They are going to give you a random point. For our problem, they gave us the y-intercept. They could give you not the y-intercept, and you would just use another point. So I'm going to plug in my point, 0, negative 6, into this equation. So if you'll remember, 0 is my x value, and negative 6 is my y value. So my equation has y first, so I'm going to start with negative 6 first. Equals, I don't know my a, I'm trying to solve for it. Then this 0 is going to come in for my x value, so I'd have 0 plus 4. I'd have 0 minus 1, and then I would have 0 minus 3. So I'm going to solve this now. all of these numbers are being multiplied by each other. So 0 plus 4 is 4. 0 minus 1 is negative 1. And 0 minus 3 is negative 3. I'm going to drop down my negative 6 and drop down my a. And again, parentheses mean multiply. I'm going to multiply these two numbers first. Again, it does not matter the order. A negative 1 times a negative 3 is going to be a positive 3. And then let's bring down this 4. I know 3 times 4 is 12. So essentially, I've got negative 6 equals 12a. My last step will be to divide by whatever number is in front of a. So you're going to divide by 12 on both sides. Now, a lot of people are about to say the answer is negative 2, but that would be 12 divided by negative 6. It's actually negative 6 divided by 12, which is a negative 1/2. So again, if you need to use your calculator to not get that wrong, go for it. So my final answer, all I have to do is take this negative 1/2 and stick it right there, and then that's my answer. So my final answer to this equation would be a negative 1/2 for an a value, and then all of your x-intercepts that you had originally written. And that's our equation. This negative 1/2 makes sense because my graph is going down. So negative number would make sense for an a value. Alrighty, let's do another one. Ooh, we got a bounce going on. So write the equation of the cubic shown. So I've got an x-intercept here at a 1, and I have an x-intercept here at a 3. So my x-intercept's a 1. It crossed through it, so that's important to know. And then at x equals 3, it did bounce. And so it's gonna do something right there. So step 1 is to write our equation. So I'm gonna start with y equals. I'm always gonna have my a. This first x-intercept, x equals 1, will turn into x minus 1 in our equation. This 3 is going to turn into a minus 3, but if it bounced, it is going to be squared. Kind of like the last unit. My next step is I have to find a third point. You could find it. For example, we could use this number up here. That's a nice point. The y-intercept is typically a nice point. It is totally up to us. But I'm going to plug in the point. I'm going to use my y-intercept 0, negative 3. Again, totally up to you what point you want to use. So again, in a point, x would come first, y would come second. So I'm going to start my equation with my y value of negative 3. Drop down your a value and substitute 0 in for x and 0 in for x here. So again, it's not always 0. I'm just happening to use the y-intercept every single time. If I wanted to use this point for 1, I could. And then 1 would go here, and then 4 would go here. Obviously, using the y-intercept is a little bit easier mental math. So drop down negative 3, drop down your a value. 0 minus a 1 is a negative 1. 0 minus 3 is negative 3. Negative 3 squared, again, anything negative squared is going to be a positive. So negative 3 times negative 3 is a positive 9. Drop down negative 1. 9 times negative 1 is negative 9a. That looks like a 19. It is not. So I've got negative 3 equals negative 9a. I'm going to divide by negative 9, which cancels. Now again, this answer is not 3 because my numerator is smaller than my denominator. It would be 1/3. And again, take your a value, put in at the start, and that is your answer. So all of this work is to find this little a value. So if you want a partial credit on a test or something, and you wrote everything except the a value, I mean, that's partial credit. Okay? Alrighty. I want you guys to try one on your own now. So press pause, try this problem, and then I will show you the answer in 5 seconds. So press pause. Alrighty. So first off, you had to find your x-intercepts. We had one at a -1, a +2, and a +3, and they were all crossing. So there were no multiplicities in my problem. Again, -1 turns to +1, +2 turns to -2, etc. Then you could use any point you want to find your a value. Again, the y-intercept happens to always be a nice point, which would be at a 0 and then a 3. So I plugged in 3 for my y. I plugged in 0 for all of my x's. After solving this, you would get 6a equals 3. So you would divide by 6 on both sides. Again, 3 divided by 6 would be 1/2. And so that makes sense that this number is positive because your graph is going up. So if you got a negative number, that would not make sense, and maybe you made a mistake somewhere. All right. So thanks for watching part 1 of writing equations of cubics. You can now watch part 2, and then we're almost done.